Because of the low C-amp, the CRP complex, the C-amp and CRP complex will not be formed. So the cap region is not attached to this complex. And so with the absence, the RNA polymerase will not continue the process of transcribing. Or if it does, so like if there's still like a little bit of C-amp left, it will be at a much slower rate and much lower concentrations. This inhibits the operon from coming on. But let's say that the glucose is depleted, then the process we explained before will happen. So now that we have just covered the C-amp and CRP upregulation, we are going to be going over the arabinose operon. So if there is arabinose present in the media, then that will be used as an energy source to help make the enzymes that break down arabinose and metabolize the broken down arabinose to make energy. There's a regulatory region, like in other models, with there being promoter and operators. Down the line, the structural genes, B, A, and D, and that helps the enzymes that break down the arabinose. Something interesting about this process is that there are actually two operators, arabinose 1 and arabinose 2. That's indicated here with ARA01 and ARA02. The arabinose inhibitor molecule known as RSC is important to control the gene because once produced, it acts as an inhibitor that once making contact with the R operator site 1 and RI region, it will then prevent the process of transcribing the structural genes over here by forming a loop. It will actually loop onto itself, which stopping the polymerase and the polymerase from transcribing. So the mRNA that is used and produced by the repressor here, so it'd produce mRNA, will always repress unless arabinose within the media is present, and if present, it then rebinds to the repressor and then becomes an activator, stopping the forming of the loop. And with the stopping of the forming of the loop, then the polymerase can then transcribe the genes over here. However, in the case of there being no RSC or arabinose, then RLC will still be transcribed, but the ARA bad genes in the back over here will be transcribed, but at a very slow rate, producing the bad enzymes. If there is no arabinose whatsoever in the media, then nothing will be coded. If there is RSC present, however, then it will form dimers over here. It will form dimers onto itself. And then these dimers are what help bond the loop over to stop, to fold the gene segment and stop the polymerase to sit on the promoter. And then once it sits on the promoter, the polymerase cannot end up going through and transcribe the genes. If both are present, then the activator, as mentioned before, will prevent the folding of the segment, keeping it linear, and then allowing for the transcribing of the genes through. So that is the video, and I hope you enjoyed it.